In the last video, we talked about the main operations of functions. So you can add, subtract, multiply, and divide functions. But there's also a fifth operation called composition. So to compose two functions is to use one as the input of the other. The notation is FOG. That's a little open circle, kind of like a degree sign. And you can also see it written F parentheses G parentheses X. Once again, I like the second notation better because it's easier to see that instead of an X here, F of X, we have a G of X. So that's reminding you, you replace the X's in the F function with the entire G function. So let's do a couple examples. F of X equals X squared minus 1 and G of X equals 2X plus 5. So first, part A, let's find F of G of X. This is the same thing as F parentheses G parentheses X. So instead of an X here, we have a G of X. So instead of an X here, we're going to put this whole entire function in. So I still have everything squared and I still have my minus 1. Now simplify, and simplify means to distribute and combine like terms. So I need to distribute the squared, which in this case you can't really just distribute a squared, you have to actually FOIL it out. So distribute your 2x and distribute your 5. 2x times 2x is 4x squared, 2x times 5 is 10x, 5 times 2x is 10x, 5 times 5 is 25, and don't forget your minus 1 is still hanging out at the end. Combine like terms to get 4x squared plus 20x plus 24. Do not factor this because we want it simplified, which means you want it no parentheses, distributed. Don't factor. Okay, so f of g, plug all of the g function in to your f function and simplify. Let's do part B. Let's do g of f of x. So this is g parentheses f parentheses x. Instead of an x here, I have an f of x. So instead of an x here, I'm going to put all of this function in. I still have my 2 in the front, and I still have my plus 5 at the end. Distribute and combine like terms. So distribute your 2 and combine like terms. These are both like terms here. I can add them together because they're on the same side of the equal sign. So negative 2 plus 5 is 3. And we're done. So this shows you something really important. F of g and g of f are two completely different functions. So order matters. Really important. F of g of x is not necessarily the same thing as g of f of x. One other way that you can see this, just straightforward before we do a different example, is part C. I could ask you to do f of g of 3. So just like in the last video when I had a number, I can plug in the number. I have two options just like before. I already know what f of g is, so I could sub 3 into f of g of x, which we found in part A. Or if you don't know what your composed function is, sometimes that's a lot more work. I can think of this as f g3. And so I can figure out sub 3 into g, and whatever answer you get out of that is what you're going to sub into f. Let's do the second version first, since I'm thinking about it, we might as well. So I'm going to figure out first what g of 3 is. So sub a 3 in here, so that's 2 times 3 plus 5. 2 times 3 is 6, plus 5 is 11. Oh, this is going to be big. Okay, so now I got 11, I'm gonna plug, so this all equals 11, I'm gonna plug an 11 into here. So 11 squared minus 1, 11 squared is 121, minus 1 is 120. So that's your second option. If you don't know what f of g of x is, plug it into g, then whatever number you get there, plug into f. If you do know what f of g of x is, sometimes it's less confusing to just use that equation. So we figured out that f of g of x was 4x squared plus 20x plus 24. So I could sub a 3 into here. Oh geez, and that's gonna be a lot of work. Okay, so this would be a 9 times 3 is a 36 plus 60 plus 24 equals 6, 7, 8, 9, 10, 11, 12. There we go. Perfect. Yay. So they equal 120 regardless, whichever way you do it. It's just your call. Okay, so composition order matters. You put the whole function into the other one, or the whole function into the other one. And you can sub in specific numbers if you wanted to, but you don't have to. Well, you do have to if the problem gives you a number to plug in. Okay, let's do something with square roots and everything too, because this is usually how we're going to practice because I like polynomials. They're more interesting. But I do want you to see an example where you don't just have polynomials, so where you have square roots. So let's do this one. Let's do f of g of x. Okay, so this is f of g of x, if that helps you figure out what's going on. So I'm going to plug all of the g function in for my x. So I have a square root m plus 2. Simplify, so that means distribute and combine like terms, but I don't have like terms here because, yeah, these are both constant whole numbers, but this one's under a square root and the 2 isn't, so I'm done. Okay, let's do g of f of x. All right, so g of f of x is the same thing as g parentheses f parentheses x, so I'm going to put all of f into my x. So I have square root x plus 2 minus 1. Distribute and combine like terms if you can. So in this case, I can add the 2 and the negative 1 together because they're both under the square root. Here's your final answer. Reminder, just like before, you can figure out your domains. Remember, you use your normal square root properties, you use your normal logarithm properties, and your normal denominator properties. So from the first example, I don't have anything here, so the domain, let me write that in red, is negative infinity to positive infinity. Same thing here, I don't have square root, log, or denominator, so there's my domain. This one's a little more exciting because now I have a square root that I can set greater than or equal to 0, so my domain is bracket 1 to infinity. And then this one is a weird domain, or different from my original square root, but it's still a square root, so just still use your domain properties. So still set this greater than or equal to 0, so this is negative 1.